Hi guys, what's up? I'm Sonu and you're watching Mathematics Expert channel. In this video, I'm going to discuss problems related with the relation. Now I have a first problem. Check whether the relation on the set R of reals is reflexive, symmetric or transitive. Whether where a relation is equal to A collection of ordered pair AB such that A less than equal to BQ. Now check first reflexivity. Now check first reflexivity. Reflexivity. First check reflexivity. Since as we know A less than equal to AQ is not true. Not true for all A belongs to real because you know what is the condition for reflexivity. The relation which is called reflexive if every element is associated with itself. So that's why I have chosen A. Now A less than equal to AQ, that is A is associated with A because the definition of relation is A less than equal to BQ. That is we have to choose two elements, but in reflexive relation we have to choose one element and that element related to itself. So A less than AQ is not true for all belongs to real because just say for example if A equal to 1 by 2 then A is greater than 1 by A is greater than AQ because A is 1 by 2 and if this is 1 by 8 so this is greater than, so A less than equal to AQ, this is not true, it is true only for A greater than 1. So R is what? Not reflexive. Not reflexive. Now check the condition for symmetry. Symmetricity. For AB belongs to relation A less than equal to BQ did not imply need not imply B less than equal to AQ, that is A related to B need not imply B related to A because as see example as an example if you take A equal to 1 that is true for B equal to 2 but 2 less than equal to 1Q, this is not true, that is 1 related to 2 but 2 not related to 1, that's why symmetricity also gets fail. Now check the condition for transitivity. Transitivity, you know for transitivity we have to choose three elements. For A, B, C belongs to R, A less than equal to BQ and B less than equal to CQ also need not same condition here, need not imply A less than equal to CQ. Therefore, A related to B and B related to C, this not imply what? A related to C. So consider example as an example we find that now suppose take 100 related to B and 5 related to 2 because 100 related to B 100 related to 5 because 100 is less than equal to 5q, 5 related to 2 because 5 is less than equal to 2q, but did not imply but 100 not related to 2, that is 100 not less than equal to 2q, 100 is greater than less or equal to 2q. So therefore the lesson is not transitive. That is, given the lesson is not reflexive, not symmetry, and not transitivity because it not fulfill the condition for all symmetries and reflexivity and transitivity. That is, R is not equivalent relation. We can also say. Now I have a next problem is sorry. I have a next problem is question number 2. Let R, that is relation, is equal to 3 3 6 6 9 9 12 12 6 12 3 9 3 12 3 6 be a relation on the set A is equal to 3 6 9 12. Then the relation is reflexive and transitive only, reflexive only, and equivalence relation and reflexive and symmetric only. This is the question of AITRI 2005. Now, you know what is the condition for reflexivity? Every element related to itself, then it is called reflexive. Just check whether it is satisfy or not the condition for reflexivity. Here is 3 3, so here 3 3 also available. For 6 6 6 also available. For 9 9 9 also available. For 12 12 also available. So it is fulfill the condition for reflexivity, that is given relation is reflexive. Now for check transitivity. For transitivity, what is the condition? If AB belongs to relation, then BA must belong to relation. Then the relation is called then the relation is called symmetric. And also, if AB belongs to relation and BC belongs to relation, then AC must belong to relation. If AB belongs to relation and BC not belongs to relation, then there is no condition for the say transitivity. It will be transitive relation. So just check 3 3 available, 6 6 available, just 3 3 available. Just check where it is the ordered pair which starts from 3. There is the here the ordered pair which starts from 3. Then first just check whether it is 3 9 available or not. 3 9 is same here, so it is available. Now 6 6, just check whether it is any ordered pair start with 6. This is here 6 12, then just check 6 12 available is not, 6 12 is same here. For 9 9, just check there is no available. For 12 12, no, not available. And all are 3 12 not available. So this is reflexive and transitive. Reflexive only, not true. And equivalence relation, because just check for equivalency whether it is symmetric or not. 3 3 available, 3 3 3 3 3, here is all are same, but 6 12, then just check whether it has a 12 6 or not. There is no 12 6 3 9, so it is not a symmetric relation. So if this is not symmetric relation once, then we can say this is not a equivalence relation. That is, given relation is reflexive and transitive. So option A is correct. This is the question of AIEEE 2005. Now our next problem is AIEEE 2004. Given relation is equal to 1 3 4 2 2 4 2 3 3 1. Be a relation on the set A 1 2 3 4. Then the relation R. It's reflexive. For reflexivity, you know what is the condition for reflexivity. Just check whether every ordered pair has a special type of element such that every element related to itself. Just check There is no. There is no any ordered pair in which every element in which first element is associated to itself. Thus, first option is wrong. Now for transitive, it is 1 3. Then just check where is any ordered pair which starts from 3. There is 3. Just then for 1 1 must belongs to relation, but 1 1 is not here. So it is not a transitive relation. Now for this question is saying that not symmetric option. Just check 1 3. There is any 3 1 option. There is 3 1 option. 4 2. There is any 2 4. There is 2 4. 2 3. There is any other ordered pair 3 2. There is no 3 2 ordered pair. So it is not a symmetric relation. Just see the option correct. A function. You know what is the condition for function? For function, every first element of the ordered pair has unique image, that is unique second element. Just check here, you see here carefully. For 2 there is a element 4 and also a element 3. So it is not a function. I have a next problem is that very interesting problem. It is also at IEEE 2006. The question is saying that let W denote the words in English dictionary. English dictionary define the relation R by R is equal to collection of all ordered pair XY belongs to W cross W. That is the Cartesian product of the sets W. The words X and Y have at least one letter in common. Then relation is. Just check solution clearly. Same element XX belongs to relation for all X belongs to W. So R is reflexive because for every element X and X, if you do Cartesian product, then at least one element should also come. So it is reflexive. Now let X, Y belongs to relation, then YX belongs to relation as X and Y have at least one letter in common. One letter in why one letter is common? Just see by example. Just see example. Just suppose let X equal to India, and take Y is equal to Bombay, and Y is equal to Bombay. And just check, let Z is equal to suppose Joker. So X has a X and this and this. If you do X Y, so you say belongs to relation, that is India and Bombay belongs to relation, then they have a common letter is A and A. And suppose YX belongs to relation, then there is also common relation, common letters A. But if you say XY belongs to relation and YZ belongs to relation, is this imply XZ belongs to relation? Just check. XY belongs to relation, that is they have X and Y has a common letter is A. YZ belongs to relation, Y and Z has a common letter O. But it has a common letter A and it has a common letter O. Then XZ belongs to relation, whether it is not. So it has no common letters. So this is not a transitive relation, as no letters is common. So relation is reflexive, symmetric, but not transitive. Just check where this option. First option is not reflexive, symmetric and transitive, which is wrong. Second option reflexive, symmetric and not transitive. This option is correct. So answer is B. This is the problem of IEEE 2006. Just I am leaving a homework. This problem is try yourself. It is the problem of IEEE 2008. I have discussed similar type of problems where too much questions, so you can apply your mind and just check the which option is correct. Thanks for watching. I am stopping here.